Welcome to Spring LIB.
31.44, we imagine we have a series RLC circuit with an EMF produced by an AC generator with an amplitude of 220 volts, a frequency of 400 hertz, and then the given values of the components. So we want to find what the capacitive reactance is, what the impedance is overall, what the amplitude of the current is, and then the next three parts is we imagine putting an extra capacitor in series with the same value, and then whether these increase, decrease, or stay the same. So for part A, we know that the reactance of a capacitor is 1 over omega times its value. Now we're given the regular frequency, so we have a 2 pi f times the capacitance. So putting our numbers in, we get 16.6 ohms. So the impedance is going to be R squared plus the inductive minus the capacitive reactances squared. We already just found what the capacitive reactance is, so we don't need to find that again. This is R squared plus 2 pi FL minus XC squared. Drag our square root sign all the way across. So the total impedance is 422 ohms. So now the amplitude of the current is equal to the amplitude of the EMF divided by the magnitude of the impedance. So this is 0.521 amps. So now we add an extra capacitor. In series with all this, so we'd have something like 2 capacitors, both with value C, a resistor, and our inductor. Then either end of this is connected to the signal generator. So this is proportional to the equivalent capacitance under 1. So putting capacitors in series decreases the capacitance. So C equivalent is decreasing when we add this. So its reactance will increase. So recall from the previous screen that the impedance is R squared minus the difference between the inductive reactance and the capacitive reactance squared. So we saw that the capacitive reactance increased, which means that this difference here will decrease, And indeed, we can actually just evaluate this and find that it's 408 ohms, which is less than the 422 it was originally. So the impedance has decreased. And then for the current, so this is inversely proportional to the impedance. So if this decreases, the current will increase.